Okay, so we have to do this right. So we'll go back to whiteboard, right? It's good, right? Let's see how many of you have done, right? Sanajit, yes. Okay, so we will adjust. This is enough. Okay, guys, right? Right. Okay. 2018 past paper. 2018 past paper. Corporate forces, right? Quickly we'll do 2018 11. So what they say, a system of forces in OXY plane. OXY plane consists three forces. So OXY plane, if they say OXY plane, then you have to draw that. Okay, so this is y-axis. This is x-axis. Okay, so OXY plane you have to draw. This is y-axis. This is x-axis. Okay, guys, right. So let's see. 3pi plus 2pj. So what do you mean by so? We learn in vector. So it's a vector notation. 3pi plus 2pj. This is a force, right? This force is acting on the points, right? Acting at a point, right? So 3pi means, what is I? I is the direction. It says I is the direction. So this is the direction. So I direction means this direction. So normally 3p in this direction. 2p means j direction. If it's minus, down. If it's minus, in this direction. That's it. So you have, this is the force. This force act on, there is a point, minus a to a. So where is a minus a to a? So you have to mark there. Minus a to a. Where is minus a? Somewhere here, minus a. Minus a to a. To a is up, isn't it? So somewhere here, I mark that minus a to a. At that point, I'm going to mark in this. So what I can do, I can mark the forces by blue. Then you can identify easily. So this is 2pj. So this is 2p. This is 3p. Okay, that's fine. This is O. Next one, 2pi minus pj, where 0a. 0a means x is 0. So somewhere here. So somewhere here. So 0a. 0a. 0a means x is 0, y is 0. Correct, no? Right. So at that point, they put 2pi. 2pi means in this direction 2p and minus pj, downward speed. That's it. Downward speed. Okay. So if you want, you can, I can zoom this, but now not now. It's okay. Okay, now it's okay, right? And there is another one, minus a 0. Minus a 0 somewhere else here. So it's a minus a 0 is this point, right? So are you okay? Yes, minus a 0 is that point. So minus a 0 at that point, 2pi, no, minus pj. So minus pi. So this is minus p. Then don't put minus here. So minus direction. So put p. Don't put minus p there. And 2pj upwards 2p. So 2. That's it. Any problem? Acting. Where p and a are positive quantities measured in the newtons and meters. Right. Very good. Respectively. Very, very good. Show that the clockwise moment of the system of about origin is 12 pa Newton. 100% sure you can do. 100% you would have done this. Yes or no? Yeah. So you have to show that moment. So it's easy now. About Anti-clockwise or clockwise, what they say? Clockwise moment. So this is this one. This is a clockwise moment. Say there is J, G, about O. So how to do that? About O, this is 2p positive. 2p into what is the height? A. And what about this? Plus, still plus, yeah. 3p into, so the 3p, what is the height? 2a. 2a is the height. Okay, so this is 2p, or that is also rotating in this way. 2p into, what is this length? That is a. Okay, so all are this one, 2p, that is also 2p. 2p into, what is this length? A. Okay, so if you go through this, 2pa, 6pa, 2pa, 2pa. So 2pa, 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 6pa, 6pa, 12pa Newton meter. Is it clear? Yeah, that's all. Very easy, marking and taking moment. Also show that the system is equivalent to the single resultant force of magnitude 5p Newton and find its direction and the equation of the line of action. Right. Then this the whole system equivalent to, okay, the whole system equivalent to y-axis, x-axis. About O, we learned that you can put the y value, that means resultant component, y component and x component anywhere on this place, anywhere. So wherever you mark, at that point, the couple will come. So if you mark somewhere here, about that, with that point, that resultant, there will be a couple. If you mark here, with that resultant, there will be another couple. If you mark here, another couple. So you can mark anywhere. We don't mind. Okay, so this guy says, okay, so there are two methods to do this kind of question. We have to show that the magnitude of the force is 5p. That is, I can mark somewhere here. But I know that about O, I know the clockwise, what do you call, um, moment. So I can mark here. This is capital Y, capital X. And I know that this G is known value, 12 PA. So if I mark the resultant through the O or Y and X, then I know that is, what is that? I know the couple. Do you understand? So, okay, if you don't like that, so really if you want to find the line of action, then you can mark somewhere else. Here, you can mark here. You can mark here, Y and X. So that point we don't know. That point. That point I don't know. I say X and Y. That point I don't know. So do I need to mark the couple? You can mark the couple, but if you want to find the line of action, don't mark. Because line of action means the single force without couple. Okay, then only line of action will come. So this sometimes if I mark like here and if I do that, it will be complicated. But not complicated actually. You can take the moment about O, no problem. Why there is no G? Because I am going to find the line of action. So if you take the moment about O, moments of the forces equal moment of the result. So here, moment of the forces will be, if you take this 12 PA, here, just distance this. Okay, distance this. So you will be finding x and y related one equation, x and small y, because we know y and x, we are going to resolve that. So since the small x and small y, that means coordinate related one equation means that is the equation of the line. So that is line of action. Is it clear? Okay, so there are, you have to think about it. Okay, so if you can't understand what I say now, then you may go, okay, mark y here, x here, g here. After, right, after this can be converted another way. This can be converted there. So, or if you don't want to, if you don't like to put x and y, if you don't like to put the point x and y, no problem. You can erase it. Put as usual what we do. As usual, what we do, we put somewhere here, this y and this y, and at that point, We don't put this is 0, no, y value is 0, no. We don't know this a. This say a, not a, actually x naught. And you can find the x naught also. You can find the x naught also. So after finding the x naught, you know the one point, you know y value, x value. So you know the gradient. So if you know the gradient and the point, you can find the equation. That is also another method. So there are so many methods to do this question. So if you want to do straight away, I will mark somewhere else. I'll put x and y because we know that we had to find the line of action, equation of the line of action. So I have to express that in x and y. Got it? Is it clear? Okay. So if you don't want to go with that one, I mark somewhere else here, and I can take the moment and I can find this x naught. Since I know the point, I know the gradient of this y over x tan theta is gradient. So I know the gradient, I know the point, then I can find the equation. That is also possible. Both are correct. Okay. So in this case, if you are very good in coplanar forces, then what you will do, definitely you will mark somewhere here y and x, and this is simple x, simple y. Don't mark the g because you are intending to find the line of action, and we know when the single force goes through the line of action, there is no couple with that. Okay, right. So I will do in this way. So I'm going to resolve y. How to find the y? 2p, 2p, 4p. So write 2p plus 2p, 4p. That is y. Horizontally x. 2p, 3p, minus p. Is it 2p, 3p, minus p? So that is going to be p. That is also 4p, is it? Then there will be a problem. No? So it's a problem, right? There's a problem, right? Isn't it? So what they say, you have to show that the magnitude is a 5p Newton. No? So it won't be 5p. So is that question is correct? 2p, 3p, 2p is correct? Yes. 2p minus p is correct? Correct. This is minus p. This minus p, I didn't put it. Why no? 2p, 2p I put, but I didn't put minus p. This, that's why. So now it's 3p. Now it's okay. Now it's okay. Now everything okay. So what is the resultant? What is resultant? R equals p square root of 3 square plus 4 square. That is 5p. Once you give the magnitude, you have to give the direction. So theta equals, when you give, you do like this, no? 3p, 4p, and this is going to be theta. Tan inverse 3 by 4. That's it. Now we have to find the line of action. So straight away shall I find the line of action? So other parts you can do, no? So many questions we have done in normal way by putting somewhere else here. So now I introduce this one. So now you can follow this. That means if they are coming up with the axis, y-axis and x-axis, then don't go for this one, the marking on the x-axis or something like. Just straight away put x and y. And y value, that is, what is y value? 3p. What is x value? 4p. What is theta? I know this theta. This is line, this is the line. You know, this is going to be line, something like that. So this is the 5. So this is a line of action. This is the line of action. So you have to find the equation of that. So you know this is theta. That is m, you know. Tan theta, you know that. Okay, so if you know the one point, you can find it. That is normal method. But if you mark like this x and y, it's a variable, no. So by taking the moment, you can find using one shot. So shall I erase this one? Okay, I erase this. Hope you copied this. So what I can do, so take the moment about O in this clockwise, then I know that that is 12 PA, that equals, now moments of the forces equivalent to moment of the resultant. Moments of the forces equivalent to moments of the resultant, right? So in that case, if you take moment about O, for this one only 12 PA. For this one only you have that resultant. There is no couple or anything. So it's rotates in this direction. So 4P, I go for the 4P. 4P into, that's the horizontal force. You have to put the vertical height y. Okay. Then this is this against this. So minus 3p. So it's against this. So this is a vertical force. We are about the horizontal distance x. So this is the equation of the line of actions. So if you divide by 3p, not 3p, all p. So what you get, I can start with here. Y minus x equals, not y minus x, 3x, 4y minus 3x equals 12a. Okay, so if you bring that ax plus by plus c form, that's the equation of the standard equation of the straight line. So if you go that way, it's 4y plus 12a that equals 0. So this is the line of action. That's it. If you check the scheme, it will be there. So I erase this one, just solving no. I erase this one also. So this is the easiest subject to learn. Okay, easiest. Give me a second. Right. Okay, so then what we can do is quickly. So now it's finished. That means the whole system is reduced to this single force 5p, and we know the equation. We know the equation. That's the equation of the line of action. Also, we know. So and on that line, any point, result. That's a result. Resultant is on the line, right? Through the line, right? Okay. So now an extra force is introduced. Now I told you, if they say extra force or anything extra moment or anything, you have to treat as a new question. Okay, completely have to change. This is a new question. So now new question, right? So if the 5p Newton, okay, so it shows the extra force is introduced to the system. An extra force is introduced to the system. The new system is equivalent to the couple with the clock wise moment 24 pa Newton meter. Find the magnitude, direction, and the equation of the line of action of the extra force. My goodness, there are many methods to do this kind of question also. Now I erase this, right? Because I don't want. I don't want. I don't want. I want this, but I don't want anything. I want that one, so I'm going to draw that again. That's right. Okay, y-axis, x-axis, O. That's it. That's it. Nothing to worry. Now see, this one I'm going to draw. So I know the line of action. This is the line of action. I know where it cuts the x-axis and y-axis. I just wanted to know when y equals 0, x equals minus 4a. When y equals 0, x equals minus 4a. Minus 4a means somewhere here. It cuts there. Okay. When x equals 0, y equals 3a. Somewhere here. So I know that line of action. Okay, so I use different color marker. This is the line of action. I know this point, that is 0, 3a. I know this point minus 4a 0. And you can mark anywhere that 3p, 3p, 4p, 3p anywhere. That's okay. Hopefully this is correct, right? So okay, this is the line of action. This is the one. So what is the resultant? Resultant is 5p. That's it. You can anytime you can resolve the 5p horizontally and vertically. That concept you know. Okay, now what they say, they introduced another system, another force to the system, so that the new system equal to the couple. So that means if they introduce another force in this direction and same 5p through the line of action, what will happen? This will be in equilibrium. Why? There is no couple, like single force. So the same line of action, if you apply 5p Newton, then resultant is 0. Then moment is 0. So this will be reduced to the single force. You know that. Okay, right. But this guy introduced, but it is not reduced to the single force or anything. It reduced to the couple. That means definitely we know that introduced force is also 5p, and which is parallel to but against to this, the same direction but against to this. That is clear. That is clear. No, introduced force is against to this. That's why the resultant force is 0. So now I erase this one also. Okay, so now I told you we have to treat this as a new one. So new one means after introducing the new force, you have to equate this to what they say. They say it is about what they say, reduced to about, okay, clockwise equivalent to the clockwise, uh, 2 so 2 pa Newton meter. So this is only the moment, no, so only the couple, no, only the couple mean any point if you take the moment, that same answer will come, because if there is a no resultant force, you can take a moment about any point, that results will be same. Okay, so same value will come, that is equal couple. The system is reduced to the couple. So if the system is reduced to couple, you can take any point. You can take the moment about any point. So I hope I can take about this one. So y x. So this is only reduced to the 24 pa. So this is equal to this, not this. I have introduced the force. I know that force somewhere here. I don't know. I don't know. It can be here or here. Actually, I don't know. So I just mark somewhere here. So rather than marking that 5p like that, mark like this. That means downwards 3p, and this is 4p, no? So horizontally, but against this direction. But I don't know that point. So I don't know that point. So I may put x naught and 0. That's it. I may put x naught and 0. So this system is reduced to the couple. And that couple equal to 24. So I can find the x naught. So since I can find the x naught, then I can find the x naught. I know the gradient. I know the gradient. I know the 1 point. So I can find the line of action of introduced force. It's clear. So that is normal way. So rather than finding this, what you can do, there is always option. What is that? Say the force is introduced somewhere here. This is 3p. This is 4p. Okay. So that unknown points. So I put x and y. So I have to get the equation. The equation should contain x and y. That's it. So I can write like this. So if I can take the moment about this point, no problem. This point, no problem. Even this point, no problem. Then you have to come up with a one equation. That's it. Okay, you had to come up with it. So this method is easier than anything, rather than finding the point and finding the point and then finding the equation. Just straight away you can find the equation. Say how you are going to find it. So this piston is equivalent to the couple. So you can take any point. So I wish to take about this point, right? Then easy. Then and then I can avoid 5p or this point. That is also easiest. Okay, if you want to take about this point, that is also no problem. That's up to you. So I can take about this point also, because I can resolve this 5p at this point, 3p, 4p. Do you understand? I can resolve this 5p any point. In normally we do in hexagon. Hexagon force is a line, no? But we can resolve here or there, whatever we point at whatever point we want, right? So same way, if you really want to resolve, I can put it here. Or if I want to resolve, I can put it here. So I prefer to take O, okay, moment about O. So I resolve here, right? So I do take the moment in this sense. So what I'm having 3p into this gap. This gap is 4a. Then 4p won't come. Okay. Then anything here? No, nothing. This only this part. This part is changed. So then about this point, no, I'm taking. Then plus 3p, yes, 3p into this a vertical force. Then I have to put a horizontal distance. And same sense, yes, same sense. This is against that. Minus 4p. Okay, minus 4p and y. Okay, so everything finished? Yes, everything finished. This equals 24 PA. That's it. So now if you simplify this, answer is there. How to simplify? This is 12 PA. This is 24 PA. So first of all, I cancel all the P. So now I can write 12 PA, 24 PA, then 12A. Why? Because I cancel the P also. 12 PA minus 24 PA minus 12 PA, 12 PA, but I cancel the PA also. So 3x minus 4y equals to 1. So what is that? So previously I got what? Previously I got which one? Previously I got which one? Previously I got the equation. What is the equation of this? What is the equation of this? That is, okay, so if you put x equals 0, it starts minus 3. Okay, minus 3. Somewhere y minus 3. Somewhere here. So it goes through somewhere here. Okay, so if you put y equals 0, so x 4 somewhere here. So this equal to this. That's why. That's why. That's why it's 24. Doubled, no? So rotate. Okay. So otherwise, so this is the answer. That's it. Finished. So it's a question. So what do they say? The question says find the magnitude, direction, and the equation of the line as x and x travels. The magnitude is what we have to do. So in that case, don't put this 4p, 3p. Put y dash, sorry, x dash and y dash and resolve vertically. Resolve vertically. So you can write down 3p equals y dash. Resolve horizontally. Then you can write 4p equal x dash. That's it. Okay, after that only you come up with this because they say find the resultant now. So the resultant is against this. So simply you can say, you can write it. Okay, so this is system is reduced to the coupled, then there is no single force, then single force must be cancelled. So, so 5p. So this 5p is the modulus mod of that 5p is the resultant, which the introduced force magnitude is the 5p. Introduced for the angle is what is that? I think same angle. And only thing is we have to find the line of action that using this technique, one step answer, no problem. So is it clear? So hope you understood this kind of question. Absolutely, now only you can realize, oh, Coplanar forces, something like that. Okay, so it's a homework is 2017, 16, 15. Yeah, you can do now 15, 14, 13, and that's wise. So I'm not going to give time in next time. Surely I'm going to do quickly one by one. Okay, guys, bye. See you. So I'm not going to wait. So I'm off. Bye. See you.